All right, first derivative test. This is the first thing that we will learn as we learn how to sketch curves. And so it's a pretty basic test. Basically, you take the first derivative. When the first derivative is greater than 0, that's saying if it's positive, for all of these x's in this open interval a, b, then f is increasing on the closed interval a, b. Okay? This is open. This is closed. Next part of the first derivative test says if f prime is less than 0, that's negative. Okay? If it's negative on this closed or open interval, then f is decreasing. So in the past we've looked at functions, and if we're given the graph, we can definitely tell still if it's increasing or decreasing. But now, you know, a lot of folks, if I gave you this 3x to the 4th minus 4x cubed, you might have trouble figuring out what does that really look like. Okay? So now we don't need it. If f prime of x equals 0, what does that mean? The derivative is 0. What all does that imply? Horizontal line. For all x's in this open interval a to b, then f is constant on that interval. All right. So here are the guidelines on the first derivative test. First thing, locate the critical numbers of f in a to b and use these numbers to determine test intervals. Okay, so a critical number, okay, critical number is where the derivative is equal to 0, or where the derivative is undefined. Okay? So those are guidelines for finding critical numbers. Determine the sign of f prime of the derivative at one test value in each interval. So we're going to break this up into intervals. So you've got from one critical number to the next critical number. Okay, and then classify each interval as f is increasing or decreasing. So let's look at this first example. 3x to the 4th minus 4x cubed. So f prime of x is equal to the derivative of that, 12x cubed minus 12x squared. Anywhere that you can think of that is undefined. Okay, just so that you have a good understanding of mathematics, where do we have undefined functions? Asymptotes, and what has to be true for an asymptote? Or what kind of functions have asymptotes?
Sine.
Okay, when the function is a rational function, or it looks like a fraction and zero's in the denominator. Piecewise functions have problems. Logs, we have issues. Okay, all of those give us asymptotes, undefined locations. Okay, holes are another undefined. And again, that's when we have a 0 in the denominator. All right, so polynomials they're okay everywhere. The domain of a polynomial is not restricted ever. Okay, so this is just a plain old polynomial, so there are no undefineds here. So then what is the other place for critical numbers?
0.
When it's equal to 0. So I want to set this equal to 0. And then I'm going to factor out a 12x squared, and I'm left with x minus 1. Everybody with me on that? So where does this equation, where is that true? Where is this satisfied? When x squared, or let's just work it out, when 12x squared equals 0, which is when x is equal to 0, or when x minus 1 equals 0, which is when x is equal to 1. Okay? So those are my values. Okay? So what is the interval that they're talking about is, if I had a number line here, I've got 0 and I've got 1. And so I have an interval this direction. Okay, it's just, I have an interval in between 0 and 1, and I have an interval that way. So the interval for this one, negative infinity to 0, and then 0 to 1, and then 1 to infinity. And why am I using open brackets here? Why am I not including the critical points? Anybody know? Okay, here's why. I'm going to test this to see if it's positive or negative. And if I pick the critical point, it's going to be 0. That doesn't tell me anything. I already know that. So I want to know, is it positive or negative? So I want to pick an easy value in this interval. So what's an easy number for me to use that's between negative infinity and 0? Negative 1. And since there's no place else on that interval where my slope goes to 0 again, I can feel confident that everywhere on that interval the slope is the same. Okay, so it's kind of like twiddling your thumbs. Okay, have you ever twiddled your thumbs and then tried to change directions without stopping? It's impossible. You can't do it. Okay, you can try, and that's the same way. If you have a positive slope and it goes up, 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 for it to go to negative, what does it have to do? It has to change direction. And to change direction, what is the slope at some point going to be? 0. Okay, that's the first derivative test. So we're going to pick negative 1 for that interval. What about from 0 to 1? 0.5. Okay, put in 1/2 there. And then what about from 1 to infinity? Yeah, let's pick 2. That one's pretty easy. All right, so what I'm going to do is I'm going to plug in, and I really don't care what the value is. I care about the sign. I want to know if it's positive or negative. So when I plug in negative 1, okay, so this is going to be 12. Okay, I'm going to back up. You can either use this factored form or you can use this form right here. It does not matter. Okay, so I'm going to use the factored form. So this is 12 times negative 1 squared times negative 1 minus 1. 12 times negative 1 is what? Or not, I'm sorry. Negative 1 squared is what? 1 times 12 is just plain old 12. And then times negative 2, that gives me a what? Negative. So that one's a negative. When I plug in 1/2, I'm going to do this down here this time. 12 times 1/2 squared times 1/2 minus 1. 1/2 squared is 1/4. 12 times 1/4 is 3. Times negative 1/2, what do I get? Get a negative. Okay. And then when I plug in a 2, I get 12 times 2 squared times 2 minus 1. This is 4 and 12 is 48. That's positive. Times 1. That's positive. So sign negative, negative, positive. So what's the conclusion here? If my derivative is negative, the graph of my function is doing what? The slope of it is what? Decreasing. From 0 to 1, what is it doing? It's decreasing again. And then from 1 to infinity, what's it doing? Increasing. Okay, hang on just a second. Okay, is there anything else you can tell about this graph? Could you kind of draw it based on what you know? I mean, there are certain things we could do already. First of all, the original function is a quartic function, or to the fourth power. What do we know about graphs of functions to the fourth power? Do y'all know what their end behavior looks like? Okay, these are both up. They're like parabolas. Okay, they're both up. Okay, so I know that, and I don't know, we can look through this and all, but this thing has the shape that looks something like that. Okay, I can tell that already, and you guys will get to that point. I don't know where the intercepts are. I mean, I know one of them's at 0. I don't know where all the other ones are. That's stuff we can find using some algebra. But I know that from infinity to 0, this thing is decreasing, and that's what I have here. It's decreasing. I know at 0, it flattens out. Okay, because my slope is horizontal. I know at 1/2, this thing is decreasing again, and I know all the way at 1, this thing is what? It's flat, and then from 1 to infinity, it's increasing. So I know this is my general shape. I don't know how far down that goes. I don't know some other stuff, but I do know a little bit. And that's where we need to kind of get to. So last year in pre-cal, y'all looked at you looked at functions, but you looked at the graph of every function. And so what we need to have a general idea of what this function is going to look like. Okay, and so polynomials either dance, they're Saturday Night Fever functions, if they're odd, or they're touchdown functions. That means both ends are up or down. Okay, this one happens to be a touchdown function because they're both up. Even degreed polynomials are up or down. Okay, both ends up or both ends down. Odd, okay, like a cubic function or even a linear function. One end is down, one end is up. Maybe like, do what? Saturday Night Fever. That's what that one is. All right. If you haven't watched that movie, probably because it's before your time. All right. First derivative test. Here's what else I know. Okay, this is important. So this is actually the first derivative test. So you take the first derivative, and then you find the intervals. You find the sign in those intervals. If the derivative changes from negative to positive at that critical point, then f has a relative minimum at that point. We go back and we look here. It goes from negative to positive. Negative, it turns and goes positive. That is a minimum. It's a valley. That's what they're saying. I don't know if it's the absolute, like the biggest minimum. I don't know if it's the lowest, but I know that compared to stuff around it, it's a minimum. Okay, that's why they call it a relative minimum. The flip is true also. If f prime changes from positive to negative, so here I've got positive slope, and then it changes to negative, that's a maximum, relative maximum. I don't know what else is happening, the endpoints and things like that, but I know that that's a maximum. If f prime of x is positive on both sides of c or negative on both sides of c, then it's neither a relative min or relative max. That's what happened right here. It was negative on both sides of it. All I know is it kind of flattens out. Okay? All right. Find the relative extrema. So that's what we call max and mins, extrema. They're extremes. So if we're talking like weather extremes, like it's really, really hot, that would be an extreme hot because the things around it, like the days around it, are normally not that hot. That's just like with our graph. Okay, it's a relative max or a relative min. Okay, so relative extrema, find them on this function right here. Thank goodness they tell us from 0 to 2 pi because that would go on forever if we didn't. All right, so what's the first step always? Very good. Take the derivative. All right, what is the derivative of 1/2 x? 1/2 minus, what's the derivative of sine x? Okay. Is there anywhere that is undefined? First of all, is 1/2 undefined anywhere? No. Is cosine x undefined for any x? No. It just keeps undulating. Back and forth, okay? All right, so I'm going to set this equal to 0. 1/2 minus cos x equals 0. How do I solve that? Yep, well, I'm going to send the cosine x over, so I get 1/2 is equal to cos x. And so now the question is, when is cosine equal to 1/2 in the interval from 0 to 2 pi? First of all, it's positive 1/2, right? So when is cosine positive? When it's in the first quadrant or the fourth quadrant. Okay, so the next question is, when is cosine equal to 1/2? Okay, that's when that adjacent, the x leg is the small leg. So that is when, let's see, 60 degrees or 300 degrees, right? Or negative 60. So when is that in radians? What is 60 degrees in radians? Pi over 3. And what is 300? What's that pi over 3 angle in the fourth quadrant? Five pi over 3. What would this is how I do it. What would 2 pi be with a denominator of 3? 6 pi over 3. So it's going to be just one less. Okay, that's kind of, I use those to guide where they are. So these are my two 0 locations in this interval, 0 to 2 pi. They keep going on and on and on. If we were to let that angle keep rotating, when it gets back around, it would be the same thing. So 7 pi over 3. And then keep going. All right, so this goes from 0 to pi over 3. And then from pi over 3 to 5 pi over 3. And then from 5 pi over 3 to 2 pi. Why did I use 0 and 2 pi again? Why didn't I go infinity and negative infinity? They gave me this interval, so they limit that for me. All right, here's my function right here. What I'm testing, 1/2 minus cos x. What is an easy interval to pick there? What would be easy for me? Anybody want to throw a number out? Sure, let's do pi over 6. Pi over 6 is going to be 1/2 minus cos of pi over 6. Does anybody know what cosine of pi over 6 is? Okay, is square root of 3 bigger or smaller than 1? Bigger. I mean, what would be the square root of 1? 1. So the square root of 2 is actually a little bigger than that. The square root of 3 is still bigger than that. So what wins the day here? Is this negative or positive? It's 1 minus something a little bigger than 1. All of that's over 2. That's negative. What about an easy one from pi over 3 to 5 pi over 3? Could do pi. That would be easy. What else would be easy? Doesn't matter. Let's do pi. All right, so 1/2 minus cosine of pi. What's cosine of pi? So minus a negative 1, right? So the minus minus turns it to 1/2 plus 1, so it's 3/2. So what is it? Positive. If I'd have picked pi over 2, that would have been an easy one also. Cosine of pi over 2 is 0. So there were a lot of easy ones in that one, but pi was just as easy. What about between 5 pi over 3 and 2 pi?
2 pi pi.
What is 2 pi with a denominator of 6? What would that be? 6 pi over 3. We're going to do 12 pi over 6. Okay, that's 2 pi with a denominator of 6. So what is this? What would be an easy one right here? 11 pi over 6. 1/2 minus cosine of 11 pi over 6. And what is 11 pi over 6 equal to? I picked that one for a reason. I picked it because it's a lot like this one, right? Pi over 6. And we've already said that they're all positive in that quadrant. So that means it's the same value as pi over 6. So 1/2 minus square root of 3 over 2. So what do I get? Negative. Okay, so now, what do I know about this? It's decreasing, increasing, decreasing. Okay, last thing. Do I know anything about extrema? Do I know if there's a max or a min in this interval? And how do I know that? Look at the back up at the top of the page. If it changes from negative to positive, then that critical point that we found is a what? It's a minimum. So mins and maxes is what we're looking for. Relative mins. So the minimum is at pi over 3, right? It's going from negative, going down, 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 down to positive, up, up, up. So this is a min. So x equals pi over 3. And I don't know on the other side. And then the max goes from positive, tick, 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 it's like a roller coaster. And then it goes down. So this is at x is equal to 5 pi over 3. And if you really wanted to, because a lot of times they want this, how could I find the y value for this? This is something that some of us struggled on that last test. How would I find the y value? Plug it into the original function. Okay, so that would be 1/2 pi over 3, so it gets kind of ugly there. But so plug in original to get the exact point. And it will be in an ordered pair. Any questions about that? Is it all making sense how this is going? Y'all ready for this one? Okay, find the relative extrema of this thing here. So I want to take the derivative. F prime of x is equal to 2/3 times x squared minus 4 to the negative 1/3 times 2x. So if I clean that up, I get 4x over 3 times x squared minus 4 to the 1/3. That's my derivative. Where are critical points located? Okay, just tell me. You don't have to give me the exact numbers, but in general, where do critical points occur? Zeros and at undefined. So do I have both of those cases on this one?
Yes.
I do. Okay, so there's a lot going on here, actually. So let's start with 0 first. So let's find when f prime is equal to 0. And when does that occur? When does a fraction equal 0? When the numerator is 0. Okay, so instead of multiplying everything through by the denominator and clearing the fraction and finding out, oh, that's times 0 and it goes away, I'm just going to set the numerator equal to 0. And so that occurs when x is equal to 0. That's a critical point. Okay, and then when is this thing undefined? When the denominator is 0. Or when the denominator is what? In this, well, it's when it's 0. Undefined is when 3 times x squared minus 4 to the 1/3 is equal to 0. And when is that whole thing equal to 0? Basically what I have here is x squared minus 4, cubic root of that. So when is that equal to 0? When the inside is 0, right? So this is when x squared minus 4 equals 0, and that's when x squared is equal to 4, so x is equal to plus or minus 2. Can this, on radicals, when we have a negative inside there, we have to look at it, right? Because if it's an even radical, which this one isn't, when it's even, it can't handle a negative inside the radical, right? Odds can. So that would be another place that would be undefined, is if this was even, like if this were the square root and we had a negative underneath, we'd have an issue. So this time we don't, because it's cube root, so we're good. So what are my intervals then? Negative infinity to negative 2. Negative 2 to 0. 0 to 2, and 2 to infinity. Okay? Questions about that? Test values. Negative 3, I like it. Test value. Negative 1, test value. 1, test value. 3. Yeah, pick the easy ones. All right, we need the signs of this stuff. So I'm going to go up to here, and I'm going to plug in. And 4 times negative 3 over 3 times negative 3 squared minus 4, all to cube root. Okay, what does this give me on top? Negative 12, so it's negative, over, this is going to be positive 9, minus 4 is positive 5. The cube root of positive 5 is who knows what, but it is what? It is positive, right? Times 3, so this is negative over positive, and what'd you get, Taylor? Negative. That's exactly what it is overall. Okay, so I got a negative over a positive. Negative 1, plug that in. That gives me the top is going to be 4 times negative 1 makes that negative 4. Y'all agree with that? It's negative. Negative 1 squared is positive 1, but minus 4 is negative 3. The cube root of a negative number is what? Negative times a positive still makes it negative. So negative over negative makes a positive. Do y'all see what I'm doing? I'm not worrying about the number. I don't care what the number is. I want the sign. Plug in a 1. So now 4 times 1 on top gives me a positive. And then I think I have almost the same thing on bottom. 1 squared is 1 minus 4 is negative. Cube root of a negative is a negative times a positive. So that's positive over negative. What does that make? Negative. Okay, and then finally 3. That's a positive on top. 4 times 3 is 12. And then 3 squared is 9, minus 4 is 5. Cube root of a positive is positive, times a positive is positive, so positive. Conclusion, decreasing, increasing, decreasing, increasing. So my maxes and my mins So it's going from decreasing to increasing. That's a minimum. So that's at x equals -2. It goes from increasing to decreasing. Maximum, that's at 0. It goes from decreasing to increasing. That's a what? It's a minimum. Decreasing, that's right. Okay, so there are my critical points, and there are what's happening, my max and mins. And how would I find out the point at which those are occurring? To the original equation. Okay, so do y'all understand what I'm when I say plug them back into the original?
Yes.